Hello, this is question 12 on your AQA paper 1 from June 2019. You have to show that this equation can be written in this form. So if you compare these two, this one has only cosec, where here we have cosec and we have cot. So what we are going to do is to eliminate that cot with this identity. With this identity. So we are going to use this one, and instead of writing cot square, we are going to write cosec square minus 1. So that means that the expression is going to be cosec squared x minus 1 plus 2 cosec squared. We are going to expand the brackets and we are going to put things in a more organized way. Cosec x. So we expand the brackets, we have 2 cosec squared x minus 2 plus 2 cosec squared x is, I can put it in the other side already, so minus 4 cosec x. So we have 2 cosec squared here plus 2 cosec squared here, 4 cosec squared, and then I have only minus 4 cosec x, and then I have minus 1, minus 2, minus 3. Yeah, and now it does like this expression where a is 4, b is minus 4, and c is minus 3. And just in case, I would write the value of the constants. So a, b minus 4, and c minus 3, because it takes nothing, seconds. Yeah, and that's the first part. Then it's a hence, which means we are going to use what we just found. Given that x is obtuse, and I will show you later how we use this information, we have to find the exact value of tan x, right? So we have to solve this equation, but instead of solving this equation, we know that that's equivalent to this one. Yeah, so we are going to solve this one because it's a quadratic in cosec. So that's the one that we are going to solve. We have 4 cosec squared x minus 4 cosec minus 3 cosec x minus 3 equals 0. This is a quadratic. If we factorize, we have 2 cosec x minus 3 and 2 cosec x plus 1 equals 0. This potentially would give us two branches of solutions, right? So the first one would be cosec x is 3/2, and the other one would be cosec x equals minus a half. Cosec is the reciprocal of sine, so the first one is telling us that sine x is 2/3. Second one, that sine x is minus 2. And you know this cannot be because sine x is between minus 1 and 1. Yeah, so it's out of range. And you should write a line saying, so don't ignore completely this solution. You write this, then you cross it out, and then you write, this is not possible because sine x must be between minus 1 and 1. So this one, writing the sine x is going to help us to see if the solution is possible, but think that they are not asking us x. So if they are asking us x, we are just going to find sine minus 1 of 2/3 and everything that we always do. But they are not asking us. They are asking us the exact value of tan x. So what we are going to do is, once we know the cosec, we are going to use the identity that we used before. So this one, we are going to substitute the value of cosec, and we are going to find cot. Yeah, but we are not going to find the angle. They don't ask us the angle. And if we find the angle and then we find tan, it won't be the exact value. We are going to have decimals. So this is not how we do it. So we come from here, and we know that 1 plus cot squared is cosec squared, and we are going to substitute that. So 1 plus cot squared x is going to be my cosec squared, so 9 divided by 4, which means cot squared x is going to be 9 quarters minus 1, which is 5 quarters. Therefore, cot x is going to be plus minus square root of 5 quarters, or plus minus square root of 5 divided by 2. This is cot, and we know that we want tan. So tan x is the reciprocal of cot, which means it's going to be plus minus 2 divided by root 5. I could have even left this that way. It doesn't matter. So plus minus 2 root 5 divided by 5, just eliminating the root in the denominator. And now we have to choose between the plus and the minus. And for that is why they give us this information. So the angle is obtuse. So you remember that the tan in an angle that is obtuse, so if you have an angle that is obtuse, so you this angle here, the tan of this angle is going to be negative, because remember the tan is the gradient, and the gradient of this line is negative. So if the angle is obtuse, the tan is going to be negative. So between these two, we are going to pick the negative one. Yeah, and they say the exact value, so we are not going to do anything with our roots. Yeah, because x is obtuse. Yeah, and that's it. That's the value of tan. So don't find sine minus 1 of this value and then find the tan, because you're going to get decimals, and they want you to do this one to have the exact value. Yeah, and that's all this question.